All right, so we've talked about how you can use the law of sines to solve for a triangle that is, for example, an angle, angle, side, and an angle, side, angle. Now there's one other type of triangle that we can use the law of sines to solve, and that is this type of triangle. So let's draw it out and we'll name what it is. So A, B, C, little a, little b, little c. All right, so I know that angle B is 35 degrees, little a is 3, little b is 5. So in this case, I have an angle, a side, and a side. So an angle, a side, and a side. Notice what that spells. So these triangles end up being a pain in the, what this spells. We're going to be appropriate and we'll call these SSA triangles, but these are called pain in the butt triangles. And that's because when we are just given an angle and two sides, there ends up being situations where there can be multiple triangles that have that angle and two sides, more than one, so two. Or there could be no solutions of a triangle that has that angle and those two sides. So I'm going to show you all of those situations and how you can check how many triangles there are. So anytime that you set up your picture and you see that you have this type of triangle, oops, I should circle this one, that type of triangle, put a little star to remind yourself that you need to check to see if there's more than one solution. All right, so when I set this up, I'm going to first just set it up like this. And then sometimes just to remind myself that I need to check if there's another triangle, is I'll like write like this, just to remind myself this would be another triangle. So I just use that little like 1 underneath to denote that it's a different triangle. Okay, so this just reminds me to check to see if there is. So I know that angle B is 35 degrees, little a is 3, little b is 5. So here's the ratio I'm going to use for solving for these, the sine of b over little b. So let's get this going. So I've got the sine of b over the side b equals the sine of a over the side a. All right, multiply both sides by a, and I get a times the sine of 35 divided by 5 equals the sine of, oops, what am I doing? This should all be a 3, because little a is 3. I need to actually erase this part too. All right, here we go, back to the game. Okay, 3, multiply both sides by 3, so we get that equals the sine of a. So now to get a by itself, we need to take the sine inverse of both sides. Now the reason that sometimes you're going to end up getting more than one answer is, remember, when you do the sine inverse, it only tells you a certain quadrant, and you've got to always check to look for the other quadrant. So we know this is positive. So when I do the sine inverse, we're going to end up getting that angle A equals 20.1 degrees. Now, remember, inverse sine only checks these two quadrants. Sine is positive here and here, so I need to also look at what if it's over here, the triangle. So that would be taking 180 degrees and subtracting 20.1 degrees, which gives me a total of 159.9. So if A, instead of being 20.1, so if I had a second triangle, I would find that second angle by doing this, and I'd get 159.9. Right off the bat, I can tell there's not going to be more than one triangle, because when I add these two angles together, they're more than 180. So angle A plus angle B is higher than 180 degrees, and you can only have 180 degrees in a triangle. So that tells me there's only one solution to this triangle, which is great. So when you're dealing with an ASS triangle, what you want to do is first solve for that one angle, and then you'll take 180 minus that angle and see if that angle that you get would actually work to create a new triangle. In this case, luckily it didn't, so there's only one solution. Okay, once we have that, I can find angle C for my one triangle. So we'll take, to find angle C, we know that angle A plus angle B plus angle C is going to equal 180 degrees. So we've got 20.1 minus 35 plus C, or plus 35 plus C equals 180 degrees. And you end up getting that angle C is 124.9 degrees. And then we can set up our ratio to solve for angle C, or side C. So I know sine of B, which is 35, divided by side B, which is 5, equals the sine of angle C, which is 124.9, divided by side C. So multiply both sides by sine C. We get C times the sine of 35 degrees all over 5 equals the sine of 124.9 degrees. Multiply both sides by 5. So that gives me C times the sine of 35 degrees equals 5 times the sine of 124.9 divided by the sine of 35. And I end up getting that C is 7.15. So we lucked out there where that triangle only had one solution. So let's look at a time when there's going to be more than one solution. Okay, let's look at another example of an angle side-side triangle. So if I draw this one out, usually when I draw triangles, I'm like, please don't be an angle side-side triangle. Please don't be one. So we'll call this guy B. That guy C, little b, little a, little c. All right, so I know that this is 15, this is 10, and this is 6. Well, curmudgeon, I've got an angle, a side, side. So I have an ASS triangle. I'm going to be polite and write it as SSA. But holy moly, that means this could be a pain in the butt. So again, whenever we have the triangles with two sides and an angle, and the angle is not in between those sides, we have to check for if there's two solutions or no solutions. So again, what reminds me that I need to do that in this case, I'm going to actually write out my different triangles like this. I'm going to use this little 1 as a subscript just to show these are the first angle, these are the solutions to the first triangle. And then if I end up getting a second triangle, and I always write this just to remind myself that I need to check for a second triangle, and then if there isn't one, I just cross it out. If that makes sense. You don't have to do this if you don't want to, unless there is a second triangle, but for me it's really helpful because I oftentimes will forget to check for a second triangle. I'm just going to make that B prettier. Okay, so let's go through with what we know. So no matter what, in all of these triangles, angle C is 15 degrees, and side A is 10, and side C is 6. Okay, so we know right off the bat, this is the ratio I'm going to go with to solve for the remaining angles and sides. All right, so let's first solve for angle A. So I know that the sine of A over side A equals the sine of C over side C. So I get the sine of A equals 10 times the sine of 15 over 6. To get this A by itself, take the sine inverse of both sides. And we end up getting that A, oops, and I should denote this A1, that the angle A for the first triangle gives me 25.6 degrees. Okay. Now this is the point where you check to see if you have more than one triangle. And the way you do that is, again, remember that sine inverse is only going to give you values in those two quadrants. Sine is positive here, but it's also positive here. So the triangle could also have that as an angle. So this angle is going to be by taking, so if there's a second angle A, it's by taking 180 and subtracting 25.6 from it. When I do that, I end up getting 154.4 degrees. Okay, so now here's how you can tell if there's legit a second triangle. So remember, all the angles of a triangle have to add up to 180 degrees. On the last example, when I added the two angles together, I got more than 180, so I knew there was not a second triangle. But here, when I add these two angles together, I get 169 degrees, which is less than 180. So that tells me there's for sure going to be two triangles. Once you figure that out, it's not that bad. You just first solve the first triangle like you would normally do, and then you solve the second triangle. So let's start with solving the first triangle. So I know angle A on the first triangle plus angle B on the first triangle plus angle C on the first triangle is going to add up to 180. So I've got 25.6 degrees plus whatever the angle B is on the first triangle plus 15 degrees equals 180. So I end up getting that the angle B on the first triangle is 139.4 degrees. And now I'll solve for the letter B on the first triangle. So the sine of angle B divided by the side is equal to the sine of 15 divided by 6. So if you guys are cool with me, with you kind of finishing this cut up, you'll end up getting that B for the first triangle is 15.07. So now that first triangle is wrapped up. So now we'll move on to triangle 2. So triangle 2, define that second angle. When I add up all the angles, you get 180 degrees. So angle A in the second triangle is 154.4 degrees. I don't know angle B. Angle C in the second triangle is 15 degrees, and I know that those have to add up to 180. So I end up getting that the second angle B is 10.6 degrees. So then to find the letter little b, again, set up those ratios. So the sine of C over side C equals the sine of angle B in the second triangle divided by the side of angle B in the second triangle. When you go through to solve that, you'll end up getting 4.26. So it's not too bad when you get two triangles. It's just you have to remember to check to see if there's more than one triangle when you have this type of scenario. And then if there are, it's like basically doing the law of sines twice. All right, let's look at another example. So if we were trying to solve this type of triangle with the law of sines, this ends up being, let's see, when I do this, an angle BC. So we've got 50 degrees, 8, and 5. So this is an angle side-side triangle. I'm going to again be appropriate and I'll write it like that. So again, let's go through my steps. Just because I want to make sure that I remind myself to check for both. I always do this. But again, if you don't want to, if you'd rather just wait until you get to that point and you know that you're going to remember, you don't need to write it like this every time. I just know that I forget. All right, so if there's two triangles, I've reminded myself to check that. All right, so I know angle A is 50, little a is 5, little b is 8. So let's solve for angle B first. So I've got the sine of 50 degrees over 5 equals the sine of angle B over 8. So I get 8 times the sine of 50 degrees over 5 equals the sine of angle B. And then we'll take the sine inverse of both sides. Those cancel. And when you put this in your calculator, you end up getting undefined. And that's because this number is bigger than 1. So this ends up telling you whenever you get an undefined, that means there is no solution. There's no triangle that has a side of 50 degrees or an angle of 50 degrees with its corresponding side 5 and then another side of 8. So again, with the law of sines, there's going to be different options that will happen. I wrote right over where this was written, didn't I? So those different options are going to be whenever you have those, whenever you get an ASS triangle, because it's a pain in the ASS, you're going to have either 1, 2, or no solutions to it. So once this happens where I got undefined, I can say no solution, which is kind of nice because then you're done. All right, now if we've got these two types of triangles, so this triangle, when I put this in, I've got A, B, C. So I've got little b is 3, little c is 4, and angle A is 30 degrees, okay? So this is called a side angle side triangle. So in this case, if I tried to set up the law of sines, it wouldn't work because the law of sines, like for example, if we were doing this guy, we'd be screwed because although I know this is 30 degrees, I don't have a value for the side of angle A, or I don't have a value for the side of A. I also don't have an angle for B, so I would be stuck with the sine of 30 over little a equals the sine of B over 3. There's no way I can solve that because I don't know A or B, and I can't solve one equation with two unknowns. Same issue happens when you have three sides of a triangle and not an angle. You can't set up these ratios to solve because you have more than one unknown. So these types of triangles, we're going to learn on the next video how to solve those two types, and that's going to be using the law of cosines.